Do you know that in the near future, by year 2025, high-speed broadband internet will be available at any location on the earth, including locations where access has been completely unavailable? As we know, the current internet available is transmitted through optical fiber cables, as mentioned in the previous video. These optical fiber cables add limitations to the spreading of the internet all over the world, as their costs, besides being difficult in construction, which leads to many parts over the earth don't have access to the internet up till now in 2020. So actually many engineers from the past started to think of finding another alternative for these cables, by some means of being wireless by using the satellites revolving around the earth. The problem is that the distance between the satellite and the earth is huge. It's more than 35,000 kilometers. So for the data to be sent from the data center to you will move a minimum of 70,000 kilometers. Because data will move from the data center to the satellite, then return back from the satellite to your device. This is a minimum estimation because actually you may be located in a place which is outside the covered zone of this satellite, so a significant delay will occur. Mr. Elon Musk, the CEO of SpaceX, announced in January 2015 the proposal of a project called Starlink to deliver the internet through satellites instead of optical fibers. Starlink is a plan by SpaceX to put 12,000 satellites into low Earth orbit that offer high speed, low latency, cheap internet access to anyone, anywhere on the planet. All you would need to use Starlink internet is a $200 pizza box-sized receiver. Each satellite will talk to 4 others using lasers as they constantly orbit the Earth, together creating a complicated smart web of broadband connectivity, as fast as the speed of light that surrounds the planet at all times and for all locations. A question that may kick your mind is that the data is transmitted with the speed of light in fiber optic cables and also between satellites in space. So, how the transmission will be faster in Starlink? In reality, speed of light isn't constant in all materials, so the speed of light is faster by about 47% in vacuum compared to glass. This offers Starlink one huge advantage, that will likely be its primary money maker. It provides the potential of lower latency information over long distances. In simpler terms, let's imagine this is as a race between data packets. A user in New York City wants to get data from data center located away 30,000 kilometers. So for this distance, the data packet will take around 147 milliseconds through fiber optic cables, while between satellites, this will take only about 100 milliseconds. In order to beam connectivity to the surface with data centers, a massive network of ground-based stations will also be necessary. So, although 12,000 satellites sounds like a lot, it's only a fraction of the infrastructure that SpaceX will have to construct. Starlink will happen in phases, but the ultimate goal is to have about 8,000 satellites orbiting just 500 kilometers above the planet, and the remaining 4,000 orbiting much higher up at around 1,200 kilometers. Starlink satellites will be 65 times closer to the Earth than geostationary satellites mentioned before, and could also offer speeds of 10 gigabits per second, which is faster than fiber optic internet. The first test satellites of Starlink, called 1010A and B, were launched on February 2018, while the last flight up till the date of recording the video was the 10th flight. It was on the 24th of June 2020, which was for 60 satellites. We are still waiting for Starlink internet to start by the year 2025, with covering the whole planet with very fast internet. So stay tuned for new videos and don't forget to subscribe with the bell to receive a notification for each new video. And thanks for watching.